Good morrow, lads and lasses, chaps and ladies. I am John Patrick Murray, JP to everyone, and it is my wonderful pleasure to tell you about random facts of science. I love science, and basically run by it, be it biology, human anatomy, chemistry, recent articles and discoveries, to many, many more things. Science has been a passion of mine for many years now, and I am personally majoring in it right now. I know a great amount of great lot, and intend to learn even more. In many cases, this isn't just something for you to learn from, but it is something that struck me as interesting, and caused me to look into it in further detail. If I learn something I didn't know, I usually will look into it. Likelihood is, you'll hear about it. But who wants to hear about why I'm into science? You're here to learn something new. Hopefully, this will do the trick. There is a certain family in the chemical table that has an adverse reaction to oxygenation and to water. That family is the alkali metals. All of these metals are soft metals and can easily be cut with a knife. They are located in group 1A, or the line down farthest to the left. The farther down the line one goes with these elements, the more adverse the reaction. Alkali metals consist of lithium, Li, sodium, Na, potassium, K, rubidium, Rb, cesium, Cs, and francium, Fr. To begin with is lithium. Lithium is the element that probably has the least wild reaction. When cut with a knife, the metal oxidizes at a slow rate, making it go from a shiny metallic to a dull blackish color within a few seconds. When added to water, it floats on the surface and gives off hydrogen gas. Sodium brings the reaction a bit more, however, not by much. When cut, the metal oxidizes a jiffy quicker and goes from a metallic to a dull color, just like lithium. When added to water, it reacts the same way, floating on the top surface and giving off gas, only a tad bit more vigorous. Now let's consider potassium. This element brings the reaction up twice as much. When cut with a knife, the element oxidizes almost to the point where you can't even see the metallic shine of the metal. When added to water, the element gives off so much heat from the reaction that the hydrogen gas that's being emitted starts to burn and a flame is seen. Is anyone seeing a pattern here yet? Don't worry, you soon will. The next up is rubidium. This element oxidizes even faster and has a much more attractive reaction to water. It blows up. When a chunk of rubidium is added to water, the reaction happens so fast that it results in a small explosion, really more like a poof. For those who have seen it, here is the pattern. The farther down the group 1A you go, the faster the oxidization, and the stronger the reaction of the element to water. Cesium does exactly what rubidium does, but only stronger. The reaction that cesium has to the water is sort of like putting an explosive cap in a glass jar. When the explosion happens, the glass breaks. The reaction that cesium has with water releases so much energy that an explosion occurs strong enough to break what it is contained in. And of course, the best is saved for last. Francium by far has the better reaction to water out of all the alkali metals. Its reaction to water is, even in small amounts, is strong enough to have this element hard to obtain. Well, that and the fact that it is the second rarest element on the planet. Needless to say, anywhere you go, it will be incredibly difficult to get your hands on it, and definitely not cheap. Right, that's about all I can give you for now. If you should feel the need to see these reactions, I suggest you YouTube Brainiac Alkali Metals. What they have to show is rather full, and in every sense is a blast. Last thing is for you to ask me questions. If you have any questions at all, just shoot me an email. It goes with suggestions for future episodes or even general comments. Excited to hear from whomever. Cheerio!